Hello and welcome to my and Michał's talk about open source firmware status on AMD platforms in 2021. My name is Piotr Król. I'm founder of 3MDEP Embedded System Consulting, Polish consulting company. I'm 12 years in business, 6 years doing open source firmware. I'm also C-level manager in various other companies. On the other side, from the community, I do coreboot contribution and some maintainership. I'm frequent conference speaker and organizer. I trained various organizations and I'm former Intel BIOS software engineer. So 3MDEP, as I said, is Polish consulting company, and what we do, we are coreboot licensed service provider since 2016. We are members of leadership of coreboot project. We also are UEFI adopters for last 2 years. We are also Linux Foundation official consultants for FWPD LVFS project, as well as Yocto participants and embedded Linux experts. We also love to evangelize about open source firmware, and definitely we want to fight to have as much open source firmware as possible. So what I will talk about today. First of all, I will try with some definitions to get back to the to maybe some knowledge that you have. What's the status of AMD platforms in coreboot? A little bit about AGESA and its history, and how the AMD support looks right now and what will be the future. And maybe I will try to answer the question, is it just about Chromebooks or maybe other platforms? And maybe a little bit about platform maintainership and some platforms which were dropped. So let's start with definition. What is AGESA? In short, it is some initialization source code for processor and memory and a couple other components which are inside CPU. We can easily call it FSP for AMD. So FSP is firmware support package. It is released by Intel. Obviously, those AGESA and FSP are binary blobs. Those are binary only components. Of course, people with NDA sometimes can get the source code based on some special relations, some fulfilling some business policy with the silicon vendor. Typically, this is not monolithic. It contains various components like platform initialization, silicon initialization, some drivers, some external interface implementation. Unfortunately, despite AGESA being compliant with UEFI's spec, and it based on reference implementation from TianoCore project, which is called EDK2, it still does not support open source toolchains like GCC or LLVM. I asked about that people from AMD directly from open source firmware group, and they said that they're working on modifications to improve that and to support GCC. Second thing that I want to talk is AMD security processor. So it is a coprocessor on the chipset which performs some similar operation to ME. So there is some security. For example, it can be FTPM implementation, some crypto support, CPU bring up, and similar stuff. There is really great talk from Chaos Communication Congress, which you can find on YouTube. And for processor names and code names and architecture names, which I will refer in this presentation, you can look on the Wikipedia how AMD say about AGESA. What is AGESA? So they're saying that AGESA roughly consists processor core subsystem, PAIM, which are special modules of PEI, UEFI phase, and Dixie drivers, which are components of this Dixie phase from UEFI. AGESA produce AGESA PPI and AGESA protocol, and those two things are used by external UEFI firmware or maybe other firmware to communicate with AGESA and get information about, for example, progress of memory initialization, CPU initialization, interconnect initialization. So as we can see on this diagram, UEFI firmware talking to AGESA PPI and AGESA protocols, and inside AGESA we have infinity fabric, which is interconnect initialization, memory initialization, CPU initialization. This is what AGESA is. AGESA 9. AGESA 9 was a closed source implementation. We know only about 2 versions of AGESA, and it seems there were no more of them. So V5 is famous open source AGESA from coreboot source. Some devices still use that. And V9 is a closed source one, which is dedicated to family 17, like Ryzen or EPIC. It uses UEFI interfaces. It integrates only with EDK2, so only with UEFI reference implementation. And at some point, it happened that version 9 could not meet firmware requirements presented by Google for Chromebooks. And because of that, there was need to modify the interfaces between AGESA and external world to meet some abstraction that coreboot can consume. Of course, obviously, coreboot will not re-implement UEFI spec, so that's why there is need for some other abstraction here. And this other abstraction was solved. It was Intel FSP. So Intel created FSP specification, which explains some abstraction on top of code which was delivered using UEFI EDK2. And since 2014, FSP created well-established environment for integration of various open source firmware projects like coreboot and U-boot. It seemed that if AMD wants to have Ryzen EPIC inside Chromebooks, that means V9 needs to get FSP support. So how this FSP adaptation was made? It was made for family 17 Ryzen and later processors. So Google was leading partner for AMD to create a Picasso FSP, which is precisely the AGESA with FSP interface. It is compatible with not only with Chromebooks, it is compatible with all Picasso based systems. Of course, this is question if we can get those systems, if we can start to port them, if those are not locked in. But at least if some OEM would like to create open source firmware for Picasso based platform, it is possible after getting all these patches for Picasso to coreboot. So after FSP adaptation, AGESA V9 conforms to FSP 2.0 specification. That's good because that specification is open. We know the interface. Of course, we would like to get rid of any proprietary code, but at least right now in x86 world, it does not seem to be feasible. Since new AMD systems typically do not initialize RAM because DRAM initialization happen before starting main processor, and it is done by AMD security processor, so there is no need for stages like cache as RAM, so to treat RAM as a cache, and that simplifies things a little bit, but of course gives us a little less control over what's going on, and we still have to deal with some secret processor behind the closed source component. This effectively eliminates FSP-T stage. This was a temporary RAM initialization phase. So V9 also contains few additional hands-off blocks. Those are kind of binary objects which are used to transfer some information from the secret world to the outside world for consumption. There are some more details in Kerry Brown's talk from Open Source Firmware Conference 2019. Unfortunately, that one is a little bit outdated because other design decisions were made. The main product for which this port was done was Google Zork Chromebook. The key point was creation of resource allocator V4, where they introduced some improvements over efficiency of device memory allocation, so there are no gaps in the memory, and it's not like we have to allocate the memory after all the reservations, but we're looking if there is any gap between the memory spaces that we can take for given device. So as a result, in 4.14, so the next release, V4 will have to also support family 14 to 16 because otherwise those platforms will be dropped. So people that maintain or have 14H to 16H platforms should care about and should support migration to new resource allocator. Of course, we as a PC Engines Firewall firmware maintainers will make it happen for our code base. From the source code point of view, from the reviews, what we can find is that first of all, if you are looking at AMD contribution, there is no contribution from AMD.com domain, but definitely the people who contributing from their own Gmail accounts or other are hired by AMD, and this is nothing secret. The diff starts saying that there was a lot of code removed from AMD, a little bit added. Still, there is a lot of patches pending, but those which were added is mostly skeleton code for new platforms like Picasso or Cezanne. What's under review? So AMD Cezanne support. This is like AMD Ryzen 5000. Of course, this mapping between the technical name and the commercial name is hard to be done, and next position is clear example of that. We also have patches for AMD Myolika, or I don't know how to read that, which is FP6 APU, and we don't know it's how to map that. From coreboot leadership meeting, we heard that maybe AMD servers will also get open source firmware support. In short, if community asking us when we can get something usable, and in short answer is that we have no idea. But what we have to say that work is in progress because of groundbreaking changes to architecture. As I said, we don't have DRAM initialization on my processor running. We have PSP that doing this, or AMD security processor. We know that right now Picasso is under finalization. And if this would be done, then all the new processor, the new processor from AMD which support no DRAM initialization on main CPU will be way faster. Of course, we see that AMD recruits firmware developers from coreboot community. So if you're looking for a job that may give you work on coreboot, maybe it is also worth to consider. But of course, 3M also looking developers, so feel free to join us. In case of other processors, like let's say Epic one, we saw from Ron Minich presentation on OSFC 2020 that that he implemented from scratch oreboot. It's written in Rust. It is fully open source so far, but there are some limitations to what was done. Everyone thinks this is like we have fully featured system, but it's not exactly like that. It was done on AMD Epic CRB. Most of the people cannot get that hardware. If we want to try that code, then we have to get some platform from market. And the question is if we can find this kind of already still expensive platform, which is not vendor lock-in. Also, if we're talking about some, let's say, consulting companies like 3M that should obtain this kind of board, but to be honest, it's hard to justify the expenses without business goals. And still there are no people that want to leverage Ron's work. And you have to know that the code from Ron initialize minimal set of low-speed interfaces, which allow, of course, booting Linux, but this is very limited usage. And if you're thinking about fully featured system, definitely there is more work that have to be done and some coordination, since this is a little bit bigger project. Other thing that AMD contributed are support for OpenBMC. So AMD Epic processors probably getting support for OpenBMC. You can find Meta AMD in OpenBMC project repositories on GitHub. This is done based on Epic Ethanol X customer reference server platform. It also, as in this screen, of course, this screen coming from Talos, so this is different. but you can see that there is Phosphor UI with AngularJS, Node.js. Phosphor UI will migrate to Vue.js soon, but this is maybe a little bit different story. So you can watch the video from OSFC 2020, which presents this effort. What about the future? So there was a lot of work done by Kiosti Malkaki and Michał from 3MDeb, mostly cleanup, fixes, and quite a lot of code as copy-paste landed in the repository for given platforms. This was multi-processor initialization tables, interrupt tables, also some ACPI code, which still have to be improved, also to take care of power consumption improvements and this kind of stuff. The platforms still keep alive and can be maintained in coreboot project. From 3MDeb side, we integrated AGESA v9 in a version that is without FSP interface, and we did that integration using EDK2. We're planning to release that integration code. So this is like because right now the situation is that using this GCC compiler, you cannot use AGESA plus EDK2. It's like it's problem because there are some conflicts between the interface. We cleaned up that stuff and would like to contribute that to EDK2 project, but this is still best effort. We're planning to do that in 2021. Of course, I don't know if this would happen, but we're doing this under Dasharo Safety Critical brand. If you don't know what's Dasharo, feel free to Google that. And this was done on some embedded platform from DFI. This was ComExpress module that we enabled. Problems we faced with that, of course, the problem with MS-ABI. This code was tested only with Visual Studio Express 2010. That's really bad. Of course, GCC didn't work, but we're cleaning that code up and want to publish whatever is there. There were some function definition mismatches and various other minor problems. And of course, some fixes could be contributed back to AGESA v9, and we're talking with AMD if this even makes sense. But knowing the history of FSP contribution and how this propagate, this will not be a successful situation. Platform maintainership. Some platforms like Asus KCM-A-D8 was dropped. So of course those were unmaintained. There was no author of the port, like nobody was interested. A lot of bugs around platforms, and that's why there was decision about dropping those. Of course there is branch on which like there's still version to which we can get back and report the platform to newer coreboot. But that makes sense for coreboot to drop not maintained stuff because they cannot move forward because of some old code which nobody can test, to be honest. A huge problem is with those platforms is that those were blob-free, fully Libre hardware. There was no PSP, there was no microcode required to boot the platform, and that's why those were very clean one. What 3MDeb tried to keep the platforms in the source code. So, for example, we tried to get funds from NLNet, but unfortunately this was rejected because the platform is very old and they don't want to spend money on some old hardware. Definitely it can be better about the RTM support. So we are TrenchBoot maintainers for AMD. We also, like Insurgo and 3MDeb, tried to revive platform, but there was no much interest in the community, not much demand for the platform, so Insurgo could not justify the expenses for sponsoring full port of the platform to coreboot or full re-upstream of the platform. So at this point, huge kudos to Thierry for going above and beyond to support that platform. Thierry, I know you did a lot of work, and thank you for that. There is still little chance that Free Software Foundation will engage to bring up the platform to sponsor this effort, but who knows, like I don't know if you have any means of reaching them. Please let me know, since at this point they did not reply to my and Thierry emails. Last hope is that 3MDEP will organize and coordinate monthly hackathons. These hackathons have to be paid because we have to spend our resources to provide support for these hackathons. But this would be smaller amount than way smaller amount than if we will do the port ourselves. So if anyone is interested in taking part in that effort, please let me know, and maybe we can bring back the KGPE-D16 to coreboot upstream. Some references, and that's it. Thank you very much.